This tutorial is another one in the series where I'm teaching people how to use causal diagrams, flow and stack diagrams, and mainly how to use a wonderful tool called InsightMaker, which is available for free, and actually within your browser you can model and you can run simulation. So I'm going to pick up where we ended up last time, and that was, let me see if I can increase it a little bit. No. So that was an example that we've done together, and if you don't remember that, you can go back into the Galaxy's blog and see how to create causal diagrams. This is an example that we've done together for SSMP that shows how, by understanding how elements in the system are working together, can impact a result that someone can see, but in reality the problem is not within one element, the problem is within the system itself. And this simple example was to do with SSMP. What we try to depict here is that marketing, and then we added another department, are requesting a lot of contracts to be validated for vendors from SSMP. And SSMP try to do their best, but there is a vicious loop here, vicious negative loop, that actually impacts significantly the SSMP perception as well. Once you start to dive in, you start to see that SSMP actually depend on HR and on legal to do their own work, and SSMP and legal are, HR and legal are busy with other tasks. So there's actually a queue accumulated in HR and a queue accumulated in legal that creates slowness in this process and has a negative impact on SSMP in the eyes of marketing. Now, when you dive a little bit deeper, what you start to see that the reason that those two departments are so slow is because of risk-averse policy that demand them to make sure that the company doesn't have any exposure from HR and from legal perspective, which means that SSMP is queued due to other department. If the company is willing to reduce a little bit their risk adverse and enable marketing and to do internal marketing purchasing, to do their own work and empowered SSMP to do more work, there's going to be less contract that are going to reach HR and legal for approval, just exceptions, and that will probably reduce the queue here and the queue here, and eventually will improve the system as a whole. But this is like an example of causal diagrams. You can see different, we call them variables, or here we use department or measurement, and you can see how each one impact the other negatively, positively. Are there any delays? What is their behavior over time? Variable data that gives you a lot of insight. But you can't do anything without it. You can't run any simulation with this example. Let me minimize. Okay, super. So what we're trying to do today is to translate this one into a flow and stock diagram. And this time I'm going to do it a little bit different. First of all, I want to run them in parallel to see how the model works, and then dive in, show you how it works in reality, so run a simulation, and then dive in and explain how it's being done. Now, as you can see, first of all the elements that exist here. So we have vendors, we have marketing, we have SSMP, we have HR, and we have legal. I convert the SSMP non-promoter score to SSMP efficiency. And there are new other variables that exist here. The first thing that you can pay attention is that part of the element or the variable in the causal diagram turn into stock. Those are stocks. And part turn into flows. The arrows are flows coming in and out, coming in and out. And some of them stays as variable. Some of them are variable that feeding. Some of them are variable that helping us with some calculation. So that's in a nutshell the conversion of a causal diagram into a flow diagram looks differently. So first of all, before we're diving in, we want to see the bottom line of this behavior. And in order to do that, I'm going to run the simulation, show you the data, and then go through it. So the first thing that we can see here is that the SSMP efficiency over time just going down and 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 down. You will see it in a second. On the other hand, the total contract that available for process are going up and up and up and up. So there's a queue here. We know it already. You just see it visually. There are more queued than available, and the gap between the queued and available actually depict here in the efficiency. So here you see the legal progress, and here you see the HR, and the other variables here as well. So I can run it again. We'll see the same result again. Let's try to run it again. And if I go and change any variables and any element within this model, we are going to see an impact on this diagram. So just let me close this guy so we can be focused here. So now we can actually increase it, and we have more space, we can see more. We grab it all to the center. Okay, so let's start with the variables. So the first one is vendors. Okay, so actually what we've done in vendors, we started with a basic number of 10 vendors, and that's all. And then we have a contract, and the contracts. So to do the contracts, what we've done a random number between 1 to 10, just to depict something randomly. Every time, so the vendor and the contract are attached. You remember here you can link, and you can do a flow, so they are linked into this flow, which is actually the number of contracts that are going to be processed by marketing. So if I'll click this guy, you can see all the parameters. And if I'll open this formula screen, you'll see that all it's doing is multiplying the number of contracts by the number of vendors. So we have a fixed number of vendors. We saw it was 10. And this is randomly. So every time a random number is going to get into marketing. Marketing has initial value of 0. So the first time that we run it, there should be 0 element here. Now there is a flow going directly from marketing to SSMP. And this is a great example of the idea of flow. So what's going on here, that this flow simply takes whatever exists in marketing and move it to SSMP. So if this sink was half full, it will take the half full of the sink and move it to here. If the sink is going to be full completely, it's going to do the same, going to move the same to here. So it's guaranteed that any change that happened in one circle of that we are running the simulation is going to move directly from marketing to SSMP. This is a really good example of bidirectional, or actually here it's one direction, it will be bidirectional eventually, relationship where data flows from one sink to another sink, and this is how it's meant to be. So now SSMP got all the contracts, every circle. So remember that we're talking here about rounds. So we see it in a second again. Every time that you're running a simulation, we define how many times we want this simulation to run. And every run, the numbers will go through here, and we will see the results. So marketing is getting everything every round. It passes over to SSMP every round. And here, if we will just draw a line between, if we just draw a flow between SSMP and HR and SSMP and legal, what will happen is all the contract directly will flow from here to here and from here to here. But we didn't want to depict it. So in order not to depict it, we just do a flow in. And this is the number of contracts that goes to review for each one of them. And we link them into the SSMP one, okay? Remember, if you want to link something, you drag it and you drop it. I don't want to do it again, and then it's going to be linked. So we linked it here and we linked it here. Since we linked both of them, there is a flow actually directly to HR, and there is a flow directly to legal. See it here. In both of them, we are simply taking all the values that exist in SSMP. This is the flow rate, and they're going to push from SSMP to HR in and from SSMP to legal. The only reason that I did it is because I can't do two flows out of n stock. So in order to depict two flows going out of the stock, I have to manipulate the system that way. So here you can see that we have initial view. The HR starts with 0, no contract. The legal starts from 0, no contract. I can make the simulation a little bit more complex if I say, oh, there was already 100 queue in legal, and there is already 50 queued in HR, and if I run the simulation, you can see that the impact is much more chaotic on the system, much worse than it used to be before. So that's just an example how I can play with parameters, and you can see the result for the good and for the bad of this model in reality. Not in reality, but in simulation. So again, so far nothing really happened. We multiple vendors by random number of contract. We push it to marketing. Marketing push it to SSMP. SSMP push it to HR and to legal for review. So up until here, pretty simple. The tricks start here. So what we want to depict here, and I have to go into a formula view, is how it's going to impact the HR out. Well, what number or how many contracts actually going to go out. And here we are going to put a limitation. And the limitation is 100. So we are going to say if, and you can see here you can use parameters. So this is the HR in. So we can say if the HR in minus 10 is minus 100 is bigger than 0, I don't want it to be 0, then take 100 contract and process them every cycle. And if not, just take the diff, process it, and push it away. And again, might be easier to see it here. What we are doing here is it's 100. So if this one is more than 100, I want to push 100 here. The left will stay in HR. If it's less than 100, I just want to take the diff and move it over here. So I'm trying to, most of the time, leave contract here. And the same trick we're going to do to legal, but this time instead of 100, we are playing the trick with 50. So it's the same idea. Different formula, but the same idea. If I minus it by 50, it's more than 0, reduce 50. If not, reduce whatever exists in the queue. So what actually happening here is that more contract coming here into HR and more contract coming into legal for review. But due to the queue, less contract coming out here and less contract coming out here. So I'm using a variable to collect all the contracts that are coming in. And maybe I don't need to open it. Yeah. So because I'm splitting it to 2, here I'm dividing it by 2. So I'm taking the number, every circle, the number of contract that's coming from HR and the number of contract that's coming from legal, and I'm dividing them by 2. And that gives me, actually help me to get the total available contract. In order to get the total available contract, I need to do a little bit of manipulation. I need to use a function called past values of ready-to-use contract. So remember that I said that it's running every time a circle. So every circle that it runs, it has different numbers. If I want to take the history of all the circles and combine them together to sum them into one value, this is what I'm doing. Sum of past values of ready-to-use contract, because I have a link, if you remember from the previous, or if you went and review it, and if not, it's another reminder. Since I use this link, if I go to the edit, I can see ready to use contract, then I can just drag and drop it and use it here in order to get data from the linked element. So link to help us to get data. The same trick, more or less, I'm doing here with the total contracts request. So this is linked to SSMP. So I'm taking here all the contract that SSMP receive each and every circle and combine them together, and to get kind of high-level calculation of SSMP efficiency, I'm just doing the total, the variable, minus the request. And if it's positive, it's a good efficiency, and if it's negative, it's a negative efficiency. And we saw all of this data again. And this is very simple simulation, very simple. I didn't close the loop here. You can close the loop it and create much more complex simulation. But in reality, what you need is what you need just to depict the problem that you have. And I think this is depicting the problem. Again, we can run the simulation. And again, you can see the gray, which is the efficiency, starting with a positive number, and as we are moving forward, just going worse and worse and worse and worse and worse and worse. And this is the total contracts, and this is the available contract, and obviously the gap between them. You can see the same relation happening here. This is the HR in. Since their queue is a little bit bigger, you can see that it's growing. It has a capacity of growing and then falling down, and the legal queue is so clogged that it just stays flat all the time. Here, if I'm clicking on configuration, you can see how can I see the data. You can do it in lines, you can do it in plotter, and you can do it in table. I'm just going to show you the table. So you can see the same numbers, you just see it in numbers and not in diagram. And I can go back to configure and move to time series and apply, and I'm back to this one. Now in the settings, I can say, okay, how many simulation I can actually want to run. 30, let's make it 50, so now it will run for a bigger time. This doesn't have any meaning just for you, so it will run 50 circles, regardless if it's going to be second, minute, hours, days. It's your call. We can do a pause to interval. We can change the algorithm. I'm always stick with the fast. And we can simulation time step. We can change it to 1, 2, 3, 4, 5. Really, you can dive in. It really doesn't matter right now. What matters is that you can set up the number of circles and kind of the type of the time units of the circles. And since I changed it to 50, now this simulation is going to take more time because it's going to run 50 times. And as you can see, run 50 times, we are getting into much lower negative number that we used to do, because just it's increasing the gap because the number of contracts going up, but there is a queue there that just minimizing. So essentially I try to select something simple so it's easy to understand and easy to grasp, I hope. It takes time as any other tool to learn this system. Not so complex, basic programming needed, but not more than that. Very convenient to use data using the links. Really powerful tool. You can dive in. Next time we are going to do an agent-based diagram, which is a different way how to see, which is a different way that shows how independent and autonomous agents within the system are impacting one each other. So that's all for this time. I hope that it was useful. You can always go back, rewind it, and run it slow. If you have any question, if you need more data, if you want the model, just let me know, shoot me an email, reply back to this video, and I'll help you as much as I can. Thanks for your time. See you next time. Bye.